Welcome in. mm, Welcome. Find the dimensions of a rectangular garden producing the greatest enclosed area given 200 feet of fencing. As always, I'm going to suggest we begin with a sketch. So here's my garden. This is X. This is Y. And the amount of fence that we're given, well, this is the perimeter. So the perimeter equals 200. But we also know that this perimeter is equal to 2x plus 2y. Or x plus y equals 100. Now, let's do a little guess and check before we do anything else with some test values. So x comma y comma area. And let's test several values out. Oh, 10, 20, 30, 40, 50, and 60. So if x is 10, since they must sum to 100, we know y is 90. If x is 20, we know y is 80, and so on. If x is 50, y has to be 50. And then notice here, if I put in x is 60, y is 40, that's going to give us the equivalent area of here, 40 to 60. So I'm just going to go ahead and cross that one out. Now let's multiply across to see what area we'd get. If our dimensions are 10 by 90, we have an area of 900 feet squared. And I'll write the units right on top. If we have 20 by 80, then we have 1600 feet squared. If we have 30 by 70, we have 2100 feet squared and so on. Please take a moment to fill in the last two cells of this table. All right, so it looks like 50 is likely going to be our value. A side of 50 is going to be one of the dimensions that maximizes our area. Now let's go ahead and set up a function to prove this. So we know the area is side times side, so length times width. So that's x times y. And we also know based on this equation, the y equals 100 minus x. So I can rewrite this as a of x is equal to x times 100 minus x. So a of x is just this quadratic 100x minus x squared. And it is downward facing, since if you notice here, our leading coefficient of -1 is less than 0, so we know this quadratic is downward facing. So let's go ahead and find the x value of the vertex, which will be a maximum. So x equals negative b over 2a. In this case, that's 100 over 2 times -1. And lo and behold, that is 50. And we know that maximum area is going to be 2,500. We already worked that out here, but we can do that with this function by putting in 50. And we get 100 times 50 minus 50 squared. And you'll notice that's 2,500. So I'm going to move this to the side a little here. And then go ahead and write our final answer as a complete sentence. The dimensions oops, of 50 feet by 50 feet will produce the largest area. Please keep calm and map on.